Hello everyone. In last video, we have discussed about uniform accelerated motion where there is a velocity increase and there is a velocity decrease. For both the cases, whenever there is increase in velocity, how the velocity versus time graph behavior, and when the velocity is decreases, how the velocity versus time graph behavior for the uniform accelerated motion that we have studied. In this video, we will take one particular example which covers both the aspect where we will observe the velocity increase also and decrease in velocity also. So that example is, suppose stone or ball is thrown in upward direction until a maximum height. Suppose I am on the ground and I have thrown one stone or a ball in the air. Obviously, to throw that object in the air, and if I wish that object has to travel a long journey, a long way it has to go, then I need to put more efforts. More efforts means I am giving some kind of energy or I am giving some kind of velocity to that object. Maximum velocity I will impart by giving the efforts to throw. Now the question is the how much efforts I can put, how much maximum efforts I can put. Whether the maximum efforts will be like that I have thrown that object, and after throwing that object, the object obviously it will gain some height, the height will increase. Does it like that? My efforts are that much that that object has gone such a high distance and it has reached to the moon, and now from there it is not coming down. That much of efforts can I put? No. Practically speaking, whenever I will throw that ball in the air, obviously that ball, it will go to the certain height, it will reach to the maximum height, and once that object has reached to that height, after that the velocity of that object will go down or velocity of the object will decrease. As I am throwing the ball, from here I am throwing the ball, we will consider different positions. Now I have thrown the ball from the ground with the maximum velocity by giving some efforts. Now the ball is at particular this position with certain height. Height I have shown in red color. This is after some time. Again after some time, ball has reached this position. Now the ball has to go to the maximum height. Now suppose it has reached to this maximum height or maximum position where velocity of this ball or the object has become 0. This is the corresponding maximum height of it, where the velocity has become 0. Now, if I think of velocity versus time graph, this graph actually we have studied earlier also. Here what we will see, here at this particular position, velocity of that object was maximum. Like here, it is shown in the graph. Here the velocity is maximum. At a particular time, when time is 0, velocity was maximum. And now, as this ball is going up and up and up till this height, to the ground we have given a maximum velocity. Here the velocity is maximum, but as the ball has traveled this much of heights, particularly after reaching to this height, velocity has become 0, like is shown in this graph. At particular this point the velocity has become 0, but this is the maximum height it has reached. If we look to this graph, here velocity is maximum, here velocity is 0, here velocity is decreasing, here velocity is decreasing, here also velocity is maximum, here is velocity 0, here also slowly, or at I will say uniform rate, the velocity will decrease and it will become 0 from this maximum velocity. Right. So in this graph, if I look for that change in velocity versus time for the corresponding time intervals, time interval 1, 2, 3, 4, 5, for any time interval, if I take, then the slope of this line or the ratio dv divided by dt for this journey is constant throughout. So I can say this motion is uniform accelerated motion where velocity is decreasing. So for the half of the journey or half of the journey here till this maximum height, the velocity of that ball or the object is decreasing with uniform acceleration. Now, after achieving this height, the ball will go down. Suppose it has reached to this position. Again, it has came down. It has reached to the this position. Now, what I am saying is, before touching the ground, obvious once it will touch to the ground, its velocity will become zero. But what I am saying is, before just touching the ground, the velocity of this ball or the object will be the maximum. After touching to the ground, it will become zero. Now, here, if you observe, after this particular line, or after this line, the journey is, here the velocity is maximum. Sorry, here the velocity is zero, and here the velocity is maximum. From here to here onwards, or in this, velocity is increasing, and that velocity is increasing uniformly. Why uniformly? It is just like a free falling body. In case of free falling body, the velocity will increase. So just before touching to the ground, the velocity will be maximum, and once it will touch to the ground, at that particular time, velocity will become zero. Now, if you observe these things graphically, for this half of the journey, here the velocity is zero, here the velocity is zero, time is zero, velocity is zero here. And this graph, very important, this graph I have drawn considering that till this position where the velocity is maximum. I have not considered in this graph that that ball has touched to the ground. Just before that, or just before that, there is this position. For this position, I am saying the velocity is maximum. Here the velocity is zero. So time is zero, velocity is zero here. And this particular point where the velocity is maximum before just touching to the ground, here also we can say, here also we can see that the velocity is increasing uniformly. So like a free falling body, here also the velocity will increase uniformly. But here the uniform motion is with increasing velocity, and here it is with a decreasing velocity. Till here, if I say, if I consider till here, for this half of the journey, the velocity is decreasing. This is also uniformly accelerated motion. And for the half of the journey from here to here, or this journey, here also it is a uniform accelerated motion only, but here velocity is increasing, here velocity is decreasing. So in one example itself, we have covered the uniform accelerated motion where we can observe increase in velocity and decrease in velocity. Thank you.